Right, hello. Today we're going to graphically prove, that tan of 75 is equal to root 3 plus 2. We're going to use this with triangles. We're going to start with triangles and try and get out the correct angles from that. So first things first, we're going to start with an equilateral triangle. And each side is going to have a length of 2. Equilateral triangles means that we have the same angles, and each angle is going to be 60 degrees. Beautiful. Next step then, we're going to imagine slicing this straight in half. Drawing a big line down the middle. This line is going to be perpendicular over there. What we can sort of do then is take out the right hand triangle over here. It's going to give us 1 along the bottom for the half of 2. This length up the middle, which is going to have a right angle there still, and the hypotenuse, which has got a length of 2. We'll label this other side x over here, and we'll try and figure out what the length of that side is. To do that, we'll use the Pythagorean Theorem, and that tells us then that x squared plus 1 squared is equal to 2 squared. So the two sides, when you square them, add them together, is equal to the square of the hypotenuse. Rearranging this then, we can see that x squared is going to be equal to 2 squared minus 1 squared. 2 squared is 4, 1 squared is 1, 4 minus 1 gives us 3. So x gives us root of 3 when all evaluated. Beautiful. We'll look at the angles for this then. This remains as 60, as from over there. And you can see this is going to be a perpendicular bisector. Not perpendicular, angular bisector even, sorry. So we know that each one is going to be split in half. So that 60 will have 30 over here. And you would have the equivalent 30 on this side as well, if you can imagine it being on the left-hand side instead. Next step then, we know this length is root 3. And if you look at our target, what we've got is root 3 plus 2. So we're going to take our root 3 and we're going to extend this length by 2. And then create an isosceles triangle with this 2, that 2, and the line that would join this top point up, down over here. So I'll just draw that out. Draw a really long line. Go along the bottom, little right angle. Beautiful. So this is still 1. We've just made it a little bit bigger, but that's okay. A little mark in there, and that's going to join on here. This is going to be root 3. This is still 2. And we get to choose this length now. We chose how far to extend this line on, and we chose it to be 2 to make this isosceles. It's not to scale, but that's completely fine. The maths is still correct. These two sides are the same. Rules about triangles then, with isosceles triangles. These angles are going to be the same. Nice and easy. Let's try and fill in what these angles are then. We know this one down here is 60. We know this one is 30. So that tells us this one, due to the angles in a straight line, has to be 150 degrees. And that means then for the remaining two angles over here, because the angles in a triangle add up to 180, the remaining two must add up to be 30. Because they're the same, they have to be 15 each. Beautiful. I'm going to redraw this, but we won't have the middle line in there because this line is no longer necessary. Let's keep going like that. Still a right angle. This has still got a side length of 1. This whole side now is the entire length from down here to up here. We don't need this little dot in the center anymore. So the entire length of it is root 3 plus 2. Let's fill in the angles then. Well, this is 15. So this one down here, therefore, must be 75. Now, if we think about our definition for the tan of an angle, tan of x is equal to the opposite over the adjacent from the soccer toe stuff you learned. From that then, if we think about this specific triangle we have over here, we can say that tan of 75 is equal to root 3 as the opposite, not root 3 plus 2 even, sorry, and the adjacent is just the length of 1. So we can simplify the 1 and say straight away then that tan of 75 is equal to root 3 plus 2. Exactly what we were trying to prove.